So why should you trust me? I run our developer relations program at DataStax, which is pretty much helping developers be badass about what we do. I'm a developer. I have been for a long time, a consultant. I was a chief architect at my last company, Hobson's, which is an ed tech company. Just pretty much ran everything I can on the internet for years and years and decided to make a jump to database infrastructure because I think that's really the cool place. Everything is data. Everything is driven by data. So I've been building web apps since 1996. That was taken right downstairs at the Cassandra Summit. And I've also done some O'Reilly books and webinars and videos, et cetera. So this is everything you should do to trust me except for with a lightsaber. You should never trust me with a lightsaber. So this is also pretty much my background, and this is going to be familiar to you guys, is this whole problem of working with relational databases at scale. So like I said, I started this in the 90s, and really the choices were IBM, Oracle, maybe Microsoft, but not really, because that was back when FoxPro was a better database than SQL Server. And you had some choices coming up, like MySQL. Postgres was a cute little database that didn't have any features. So these are, Berkeley DB was a really cool choice. And DB2 ran on a mainframe. Well, they all kind of grew into this internet era, but this is the problem that I had, was the square peg problem. It didn't fit the workloads that I wanted to do. So this is the problem we've created, is everything that we do now that's on the internet creates data or needs data, and a lot of it. I mean, these things. But what about other things like IoT? IoT is a huge buzzword, but it's for real. You have Nest thermometers or thermostats. You have, I just saw there's some GPS track. The GPS tracking your kid market is huge. There's like 15 players in that right now. It's like a little band that has a GPS marker that radios the position of your child. I had no idea that was a thing. Huge. Well, what do you think you can do with that? You dump it in some database. Of course, financial services has always been a hot data market because, of course, it is just data. Gaming, also really big now, telemetry on gaming. But let's face it, I'm shortchanging all the potential use cases. These are all heavy data use. And I trace back the worst moment in my life to this day. This is when it all started to happen. This is when I just didn't have enough infrastructure. It's when this guy got on stage and said, you're going to buy billions of these things. And before that date, smartphones were not really smart, and the whole world of internet was pretty much in a browser that was there, but it was you had to go to your computer to use it. Now with these, and he didn't start, Steve Jobs didn't start a market, but sure made it hot. After that, everybody had a smartphone. And it meant that all those little apps on there had 24/7, 365, and if it goes down for a little bit, you go on the App Store and you find a competitor. And it's funny because that was around the time that Twitter was also getting hot. Do you remember the fail whale? Every time Twitter would go down, it's like you get the fail whale, and it happened all the time. And they had to fix their infrastructure because now everybody's got one of these things and they're tweeting about what they ate for breakfast or something. So this has just changed the dynamic. Now any company that's online has probably got a mobile presence or a 24/7 presence. The one that was affected the worst was financial services, banking. It used to be that banks they turned off everything when they went home. They did batch jobs at night. You didn't do banking at 3 a.m. You do now. And some of the big banks had to really figure out how to make that work. And so what did we do? We built these horrible, horrible things. I love this. This is not me. I can't claim. I don't know who actually originated this, but it is hilarious because I've actually seen pretty much this in production somewhere. And this is the classic panic architecture where I'm just going to start gluing things together that look like they scale and hope that they do. And then what happens with anything you build that's complex, complex things fail in complex ways. And this is an open door to a class of problems that I love the name, Byzantine failures. These failures that are complex, and you have no idea how that happened, and they happen. So uptime used to be, we used to rack up servers a lot. And that uptime was, add more racks. Start isolating your power domains. And that's how you got good uptime, as you're chasing those nines of availability. And then data centers became the problem, so we put in multiple data centers. That's a problem, because now you have this link between the two data centers that needs to be managed, and that's really tough. I spent a good portion of my career making this work. And it was a hard problem. It took a lot of engineering. And of course, it was a one-off, bespoke problem. You just fixed that thing. Oh, how do we replicate our data? How about DBRD? That didn't work. So I tell folks, you have a 0% chance of 100% uptime in one data center. You're just not going to get close. That's where those nines start coming in, those probabilities of failure, because a data center will fail. They always fail. Clouds fail. Well, what did we do? We went to the cloud and said, well, it's going to be different here, right? Because they're up all the time. And so we started treating availability zones like racks. So, hey, multiple availability zones and we're going to be covered. No, because now regions fail, and they do. And now the way to be up all the time is to do these regional deployments. Again, a whole new class of problems when it comes to data management and being able to distribute your data in a way that your application won't fail. That's a difficult problem. And let's face it, if you're an administrator of a database, this is chilling, because that's the hard problem. Making sure you have great indexes and your servers are online and everything is great, but uptime is your problem, always, because you got one of them. This is a little dated, but still interesting, because it shows the application downtime experience from cloud reboots, not regions going down. Like the cloud provider told you you're going to reboot your server. Thank you. You paid for that. And so AWS Reboot, one of my favorite events, because Amazon's like horrible the Zen kernel bug, we're going to have to reboot everybody. There's no option. And we're going to do it in groups. Just prepare yourself. Just panic, waves of panic. Except for those folks using Cassandra. They were like, okay, we planned for this. And that was a big moment for Cassandra, because the people using the organizations like Netflix, who use a lot of Cassandra, didn't have any downtime. Amazon rebooted everything they had. Didn't affect them. And why? Because they were prepared for it. How did they prepare for this? This is your high water mark. Do you know, have you heard of this? The Netflix Chaos Monkeys, or the Simian Army? And then LinkedIn has CMorg. That's where you want to be. That's where you want to be. Is these tools right here, they purposely break production stuff. They'll introduce latency. They'll bring down random servers. They'll inject failures into services. They'll take out regions, availability zones, kill WAN links. All the stuff that could happen to you, they do it to themselves on purpose in the middle of the day. So if you're a developer or an admin and you're deploying into that shark nest of stuff going on to your infrastructure on purpose, you're probably going to plan ahead. You're like, well, if I deploy this in production, some random monkey is going to come along and turn off my servers. How am I going to deploy this that's going to keep that from happening? And that just sets up a really good mindset. And I've said so many times to so many large organizations that when they see this, they panic. I mean, how many of you have worked at a place where they have the freeze out during a busy period? Like, no one touches anything in our data center. It's like, no, can't. Oh, yeah, we've all been there, man. I know. You can't touch anything. Oh, to touch anything, you have to get VP approval. That, to me, that's so sad, because you can't do this then. And I've asked people before, can I walk into your data center and turn off anything I want? No. Why not? Well, it will cause trouble. Then you have a problem. You've just introduced a situation where you can have downtime in really crazy and potentially disastrous ways, and you're not in control of your own destiny. So Dynamo Paper, right around the time Steve Jobs is like, buy my phone, Dynamo Paper comes out, and this is an attempt by Amazon to remind everyone that they have some really terrible infrastructure. I'm kidding, but it's actually kind of true. Because the Dynamo Paper was an effort to just kind of work around the natural entropy of systems. Things fail. Power supplies, disks, links, Ethernet plugs, everything dies. You know, there's just chaos. Millions and millions of things that can happen. And so how do you build a database that's reliable, performant, always on? It's not, they didn't build anything from scratch. They were involved in some really serious computer science, and Dynamo Paper was a part of that. Like, hey, you can have uptime, and here's how to do it. Great. And it was a basis for a lot of new and exciting systems. So, of course, Cassandra was one of them, but React, Voldemort, those are others that were out of that. There's some new databases. There's databases that use a Dynamo model, like Dynamite. It's an in-memory database. There's several databases in the world that have pulled things from the Dynamo Paper because it was really seminal. It made sense. So here's a new problem that we're solving. And it's not just uptime. Here's the other issue with distributed database. You start your company in the US, and all of a sudden you start getting big dreams in your eyes, and you start spreading that around the world. And you want to be in other markets. Let's face it, if you're here to play and to win, you're in a global sense. You know, that is what you do. And being in one region, locale on this planet, is a good starting place, but that's not where you're going to end. And you have to think about those users in those places and their experience. Are you going to send them all back to Amazon East data center? That's a really bad idea. And why? Physics. This is a sad reality. You cannot substitute this problem. There's no way of getting out of this. You know, if you take a photon of light, I know this is all a thought experiment, in a vacuum, and you send it all the way around the globe, like that. There's my great graphic. 133 milliseconds to just get that one photon all the way around the planet. That's the speed of light. That is a significant amount of time, especially whenever you think about you're chasing tens of milliseconds in your application, and here you got no chance at all. Now, sorry, this is the speed of light in the optimal position. Generally, you're going to get about 70% of that because of just the latency. The electron in copper is about 70% of the speed of light. So you're looking at over 200 milliseconds to get something around the world. And the round trip time from San Francisco to Bangalore, 250 milliseconds. So if you have customers in India and your data center is in the US, you are not giving anyone a good experience. So can't break the law, Einstein said. New problem. This is not the old problem that is just new again, is let's face it, things are changing when it comes to global trade, commerce, but data protection is now a big deal. There's the general practices for data protection from the EU that's coming soon, and it has a lot to do with borders, imaginary borders, and where our data lives. You could thank Facebook for that. Facebook had a provision where if you were a Facebook user in Europe and your data is being collected there, they brought all that data back to US to process it. And that was bad, because what they did is they basically said, we don't believe in the sovereignty of the data, and so we're going to just bring that into any country. The design was great from a nerd's perspective. You and I probably would have fixed that right up. Oh yeah, no, bring it into our big data center so we can process that data. Makes sense. We don't think in the boundaries like that, but that means now that data is subject to U.S. law. And so if U.S. Attorney's Office serves a subpoena to Facebook, they can go pull hard disks with EU data in it. So of course, nobody in the EU is okay with that. And this opens up a problem. So safe harboring data, like your product catalog data, you want that distributed all around the world, no problem. But when it comes to users, the users, I want to make sure that I'm only keeping my EU users. This is actually shows you how dated this is. Well, not yet, right? Not in England. Not yet, not yet. It hasn't happened yet. But this data now has to live within a physical boundary. With virtual thing has to live in a physical boundary. So Apache Cassandra, which is a huge part of what DataStax does, we've been working with this database for a long time because it is an application database that solves this problem. Now, I work for DataStax, and we have our own, we believe, the best distribution of Apache Cassandra. So when I talk about Apache Cassandra, yes, this is an open source project, but we also have our own version. I'll show you a little bit of the difference, but we're really proud of what we've contributed to the Apache Cassandra project, but also the things that we're bringing for enterprises who need a lot more than that, just an open source project. So that application is really the use case that we're trying to accomplish. This is not a data warehouse type application, like something that would be suitable for Hadoop. We think of things, Cassandra is better, closer to your customers. And why? Because of the way that it works. It doesn't like downtime, it loves speed, and it scales like crazy. So why the cloud? Why am I saying that Apache Cassandra is better for the cloud? And it's one thing. It's a replication story. You cannot beat the replication story in Cassandra. And it came from Dynamo, sure, but it's the only database that has survived the NoSQL wars that has that replication. And I'm surprised that no one else has done this, no other database has done this, but it is really amazing. And let me explain why. I'm going to try to convince you in the next 20 minutes that it is really that awesome. So here's probably what you're doing with a relational database. The old, it scales because I shard. Well, sharding is a mess. And from an application developer standpoint, like me, sharding is bad, really bad, because that means now I have to do things in my application to account for these shards of data and where they are, the location. There are ways to do that for sure. But it also sets up these really funny failure domains. Like if this particular domain goes down, then part of my customer base is offline. It's very strange. And it doesn't solve the multiple data center problem that we have. This is another issue that we have conveniently forgotten often, which is this 8 fallacies of distributed computing. Thank you, Sun, for letting us have that. One of the Sun, they're not here anymore, but they kind of are. Thanks, Sun. But all of these 8 are really funny because I can tell you many times where I've been in conversations with some database admin or network admin or somebody like that, and they just don't believe in one of these. Like latency is 0. Well, how come I don't have instantaneous replication? Physics. Or my network is 100% reliable. What are you talking about? We have all these redundant switches. There's no problem here. Sure, nice story. Topology doesn't change. We don't alter our stuff. Yeah, you do. All the time it happens. So these are all things to just live with it. This is the law. So replication, how does this work in a Dynamo-based model in Cassandra? Very, very good way to make this work because I'm going to show you graphically, but also in a way that you'll understand how you can work with your application. So replication, what I've done here is I've set up, these are 4 individual nodes. These are different VMs, they're different instances in the cloud, they're different servers, but they're different. They're separated from each other physically. And each one of these nodes now has been assigned a token range. Now the token range in reality is a huge 64-bit number. It's massive. you're not going to have that much data. But what I've done is I've shrunk it down to 100 tokens, so it's more human readable, like we can understand it. So I've assigned a token range to each one of these nodes. So this has a quarter of the data, this has a quarter of the data, this has a quarter of the data, this has a quarter of the data. So each node now in an even distribution is responsible. It's not storing, it's just responsible for 1/4 of the data. Now, if you'll notice over here, I have an RF equal 1. That stands for replication factor of 1, meaning I just have one copy of my data per node. And because the way that it's distributed, each node now has a quarter of the data. You probably can see the most obvious problem here is if I lose one node, then I lost a quarter of my data. That's bad. But hey, you got 3/4, so what are you complaining about? Well, this is the beginning. So how do we take this model and extend it? Now, this is where it starts getting interesting. So when you start adding replication factor, each node now is responsible for its own primary range and its neighbor's range. So we start storing more data. In this case, with a replication factor of 2, each node in a 4-node cluster has 2 nodes worth of data, or half of the data in the cluster. So now we're starting to get a little more resilient. I can lose one node, and I won't lose all my data. Now, ideally, what we want is a replication factor of 3. 3 is pretty much the magic number of replication for a lot of things. And in this case, a replication factor of 3 is what we recommend in production. And if you are in production with a replication factor 3, it opens up a lot of opportunities here. You can lose 2 nodes, and all your data is still OK. And that's really the point. We need to be resilient to failure in ways that we can predict. Now, you can't lose all your nodes and have it work. It's still not going to work for you. But the way we've designed the system, or the way it is designed, is that it gives you the most chance for failure. So things like, this is the most common scenario. Generally, downtime on a node is a lot less a result of some sort of hardware failure than a need. Let's go back to my cloud survey. A need to reboot the machine. That security patch. If you're running, I was an Oracle DBA for years. And if I needed to patch one of my Oracle boxes, I had to negotiate for downtime, right? Beg for downtime from a product manager. And they're like, well, sure, 3 a.m. on Sunday sounds great. That was awesome. Thanks. Appreciate that. But when you're in a system like this, I can do this in the middle of the day. And it doesn't affect my running system. And that's critical. And now I'm getting timely security patches when I need them. I'm not risking my infrastructure by having a security hole, but I'm also not risking my application uptime by creating downtime myself. So replication factor, great. That's distributing your data. But how do I know, now we're moving up to the application where the client is, how does the client know or the application know, hey, I stored some data, did I? That's the question. Is it really out there? If you have data spread out all over the place, the questions start coming up. Did it really get replicated? I don't know. Well, consistency is how we let the system describe what you want, and this is what it's the contract that's given to the cluster. Let me explain. So when the client is writing data into the cluster, then it says it knows where that data is going to be. It takes the primary key, hashes it into a partition number, and that partition number fits somewhere in here, okay? So in this case, I had partition number 15. It goes here. Awesome. But when I write it, I want to know how many of those replicas actually received it and committed it to disk. And that's where consistency level comes in. So this is an application programmer concept. You as an application programmer will be able to specify, I want 1 or a quorum. So the differences are here. When I specify 1, this is a little more loose with my consistency guarantee, but it is fast. So that what I'm saying is I only need 1 replica out of those 3 to acknowledge the write to disk. So it doesn't mean that it doesn't get replicated, it just means the acknowledgement. So if one server is faster than the other two, you're going to get a really fast return on that. Awesome. Now, in the case of quorum, and this is the tunable consistency you may hear about with Cassandra, quorum ups that to a new level, which means now I want 51% of those replicas to acknowledge the write or a consistent read. And that gives you some, what we call strong consistency. And it also gives you the ability to lose servers. The local versions of those are there for if you're in a multiple data center. And quorum doesn't stretch across 2 data centers, it just keeps it in one. It keeps your latencies down, but these are typical ones. There's a lot more of these. Not only is there 1, there's also 2 and 3. There's each quorum, which is every single data center has to have a full quorum, which is very high latency, but that's good if you're really paranoid about your data. So there's a lot more to these. These are just the most common ones. So let's see how that works out. Let's look at the scenario. Scenario being, client writes data, says, hey, I want to go to 15 with a consistency level of 1. It writes it out, asynchronously replicates, great. But now this node is the fastest. So if I do a write, and our client is smart enough. So DataStax, we build a client for Cassandra, which is really smart. It participates in the cluster. It not only knows what node is responsible for that data primarily, it's also really good about routing around failures and slowdowns. If you have 500 nodes in your cluster, and those are really common, and a few nodes are having a problem or the network link to those nodes is bad, then we can route around that problem and your application will never know. It is magical. But it's not magic, it's engineering, which is really close. But this node right here is going to be responding quickly, and that's what goes back. So you would use a 1 in cases where your consistency guarantees aren't really needed as much. Say like you're writing out log files or IoT data. Yeah, it'll replicate it, but I'm not asking it for full quorum. I'm just dumping data into the cluster. Good example is this. Netflix has their telemetry cluster, which collects. Did you know whenever you're watching a movie on Netflix that there's a bit stream leaving your house? Well, that's the bit rate. That's the player reporting back to Netflix. All right, here's the current bit rate. Here's the bandwidth that you're currently at. Here's the density of the playback. Here, any lag information. All that goes back into a cluster, like the position you're at. Well, that cluster is getting 1.4 million writes per second. That's a lot. And it's all that data that's really important for Netflix. They need to know. So did you know, and this is another thing, you can call Netflix and say, I'm having a lot of trouble with it's getting bad, my video is bad. And they can look at that data and say, yeah, you're on Verizon, sorry. I'm kidding. But they can look at it and say, yeah, you're having some lag. Well, that is something they write at 1 because it's not needed immediately, but they need it. They need it fast. So what about this? Writing a consistency level of 1 with a huge failure, like a whole rack went down. No problem. Our client, the DataStax client, is smart enough to say, oh, that's bad. I'm going to go ahead, oops. Oh, I got my graphic wrong. Shouldn't be pointing to that one. Should be pointing to this one, sorry. But it's smart enough to route around the problem so your application doesn't know. I've worked with customers before where they didn't know they had nodes down until they looked at their infrastructure dashboard and they're like, why is this? Oh, that's off. Well, I didn't even see it on the application. Boy, that is such a magical moment if you're an admin. You come in and like, oh, servers are offline and I didn't get a page at 2 a.m. Awesome. Because that's the way it's designed to work. So if I write at quorum now, this is upping the consistency level. It still replicates, so it goes to the coordinator, replicates. But then if I lose a server, I'm still good because I can read and write at 51% of the replicas. That's awesome. Multi-datacenter. Now this is the cool part of, Cassandra is great in a single data center, don't get me wrong, but really multiple data center, like on-prem and the cloud, figure that one out. If you are going to move to Amazon and you still have a huge amount of floor space somewhere, there's not a lot of options. What do? They'll send you a trucking container and say, load all your data in it. It's a snowball. Go ahead. So that means you just get this big fat pipe of data, but then that's a huge downtime. That's going to take a week for that to happen. You could bridge into a multi-data center situation pretty easily by using Cassandra. And there are a lot of companies doing this right now. So when you write to a single node in that data center, it does a single coordinated write to the other data center. So that's the important thing about this replication. It doesn't blast all the replicas, so it doesn't send 3 links over your WAN link. It's WAN conservative, so it only sends 1 data link, and then it sends it to 1 coordinator, which then does the coordination and replication there. So this is a situation that you know that it can handle. So if I'm writing data, it can handle that. But what about this situation, when you have a single data center down? That is the tough one. Because at this point, I have no idea if my application's even going to work anymore. And in this situation, it will. Now, I talk about Netflix because they're pretty public about what they do. They have some great talks online. So I talk about them because they're already out there. But they have an excellent talk about running active-active multi-data center applications. Active-active, not active failover. Active-active, meaning that every bit of your infrastructure is being used. You don't have idle. I loved paying Oracle twice as much for licenses that I would never use. They're just sitting there, bored, because I was looking for 4 nines. Maybe 3. All right, I only guaranteed 2, but I was really hoping for 3. Well, in an active-active configuration, Netflix can lose an entire region. Amazon East can go down. You would never know the difference. And they're able to control the experience because here in California, we go to Amazon West. We go to actually Oregon for our data. But then if I go to New York, then I'm going to Amazon East. That data is common. To keep your application online like that, it needs to be common. OK, so blah, blah, blah. All right. So now, another thing that I want to talk about is building applications with this. Now, we DataStax, we believe that data is much more than just a storage problem. There's a lot more to it, actually. So if you think about like a weather website where there's all this data being poured into a Cassandra database, which is a great use case, an IoT use case, and you're serving up that data on a mobile application, that works really well because you have a very fast, responsive, uptime database. But what we've added is this element of Spark. So you can analyze and in place all your data with Apache Spark. So we don't recommend using it as a full data warehouse, but what we do recommend is that you leave your data in your database and process it there. ETL jobs are terrible because why? It's slow and it has error. MDM is this whole thing around moving data in a very controlled fashion without losing it. Because what happens whenever you export and import data? You lose something. And it's like, what? Didn't we have some records over here? It must have fell out. I don't know what happened. It fell off the truck on the way over. So we really advocate you processing your data in place. So if you think about weather data, I need to do roll-ups, daily high, daily low temperatures. Just do that in place and write it right back into a Cassandra table. Spark jobs run awesome. And Cassandra and Spark work great, but I'll show you in a minute. We at DataStax really believe in this. I mean, we're the ones who built this. And if you're using our enterprise, DataStax Enterprise, this is considerably faster than any other solution. Right now, I'm at the point where I'm kind of sick of doing batch processing, and Spark streaming or any kind of stream processing mechanism is really the way to go now. It's because we've sped up the amount and the volume of data and the speed of data so much that you really can't count on processing it in a couple of days. It's too much. You have to people expect responsive data. They need, so have any of you been involved in these customer experience initiatives, digital transformation, anything like that? Which is, these are buzzy words, but the kind of everybody's worry. Amazon figured this out, right? Like if we're really good to our customers immediately, they'll use us. So what happens when a big company like a Target or a Macy's or Best Buy wants to compete with Amazon? They have to meet them at that place where they're really good to their customers, and that's customer experience. And the kind of applications that we're really our sweet spot is those kind of applications, because it's that responsiveness to that action. So if somebody says, oh, I'm interested in this and this, recommend something else for them to buy. I mean, how much stuff have you bought on Amazon because it said, oh, you should try this too. If you put this and this together, it's only this much more. Oh, okay, click. That's really, they figured that out. That's why Amazon's scaring everybody. So digital transformation should be renamed to Amazon, Amazon defensiveness, because that's what we're all worried about. So I'm going to go through the technical part of this so that you believe that this isn't just smoke and mirrors, and then we'll be done. Replication is built into the key space. Key space is the part of the data model that stores tables. So it's like a schema in Oracle LIM. And there's different strategies. Simple strategy is kind of the really lame default, unfortunately. Network topology strategy is the one we want to use, because that says, I want to believe that the topology is stored in the network, meaning two different data centers, than just this big homogeneous network. So when we set up our replication strategy, there's two ways to do it. We could set our replication factor just in general. So every single data center will have a replication factor by whatever number, in this case 3. Or you can get specific about which data centers have what replication count. So for instance, for my customer data, remember that problem? The EU data centers, both of them have 3 copies, but my US data center has 0 copies. And that is my data sovereignty problem. Now, and this is auditable, by the way. You can say, look, we replicate no data to the US. Oh, so you do. And the application here is this. Remember this guy? Well, if I set a replication factor of 3 in the EU but 0 in the US, you won't see a single bit crossing the wire. It won't happen. Now, how does it find all that data? And this is a funny word, snitches, but a snitch is something that it's a mechanism built into the way Cassandra works, but it's really like that. It says, oh, I know where your data should be. It's describing the topology and making the topology work for you. And so that's what gives you that awareness of this is in a different data center, this is in a different rack, this is a different node. Whenever you write that data, the client says, I'm going to put this in, but the snitch is the one that says where it should go. Dynamic snitching is really routing on this node performance, basically. So if there's a node with a problem, then it will route around that problem. Now, there are different snitches out there for there's like a Google Cloud snitch and an EC2 snitch. There's different specific ones that will give you they'll give you very specific solutions to where you're at. Mostly you're going to use this one called the gossiping property file snitch, which is a really long, ugly name. Essentially what it does is it gives you a ton of control. So you, in one file on the running node, you say, I want to know, oops, too many clicks. It tells you which data center you're in and what rack you're in. That's it. And so and this is the cool part, is when you bootstrap that new node into the system. And bootstrapping is when you add a new node. And this is an online operation. You don't have to bring down your cluster to do this. When it bootstraps in, the node announces itself to the cluster saying, hey, I'm here. Here's all me. I need to be in rack 1 and DC 1. And everyone's like, got it. And so all of those token ranges arrange around that. And then from then on, any communication done to that node is aware of where it's at. So Like, I only want to be in DC1. Okay, then that node gets data. What about data that's destined for DC2? This node does not get that data. So that's how it knows where it is in the world. So how do you set this up? If I want to add a data center, and this is just to give you some idea of the operations, but it's really not that difficult. And so whenever I want to set up a new data center, I use network topology strategy. In the Cassandra YAML file, which is really that's the configuration, I set my auto bootstrap to false. Bootstrapping is whenever you add a node to the system, it loads it with data from the cluster. I'm going to turn that off for a pretty obvious reason in a minute, but I'll get to that in a second. But we turn off the bootstrap. I add all the server numbers from over here, so it knows all of the other data center servers. I put the node location, DC2, in the snitch, right here. And then when these come online, because I turned it to auto bootstrap false, none of these nodes are going to have data. And that's good. Because what I'm doing is I'm setting up the entire complement of nodes that I'm going to have in that data center. If I set it to auto bootstrap false, each new node would get a whole new streaming. It would just be a mess because they'd be continually growing the cluster before I'm ready. This is really like a staging operation. So I do an alter key space where I add, if I need to, DC2, how many replicas I'm going to have in DC2. And then I type node tool rebuild. Thank you. And when I do that, here comes the data. And so that node tool rebuild is really, that's when the real thing starts. So that's about the end of that. I mean, really what I wanted to give you is this overview of how Cassandra works, why it works so well for a cloud, or multiple cloud, or hybrid cloud, or anywhere you need data distributed in a really controllable and efficient way. That's what I want you to take away from this, is replication in this database is amazing, and it really is unique. There's no one else that does this. And I don't know why, but that's just how it worked out. Real quick announcement too, if you want to give this a try, we just released DataStax Enterprise 5.1. It has a lot of features in there that you will not find in the open source world. And this is the one I'm most excited about, is this paging increase. So whenever you're running a Spark job, it has to pull data out of Cassandra tables. DataStax Enterprise has some optimizations, some really key optimizations that give you about 3x speed improvement over what you can do in open source. So it's really geared to analytics. The speed is pretty close to reading a CSV file right off the disk. It's pretty fast. And you can go get this today. It's a free download. Give it a try, POC. If you want to talk to us, we have a Slack channel on DataStax Academy. If you want to get on there and check it out and ask some questions, we have a Slack channel you can get in there. There's always have engineers in there watching the room. And that is about that. So thank you for being a small but attentive audience. I appreciate it. Any questions? Questions? Yeah.
So typically, I mean, when you suggested that if Amazon, for example, needs to apply a critical patch, announcement, they need to use servers, we witnessed that.
Yeah.
Painful. So you're also suggesting that we should actually, because the reason people move to Amazon is because they want to page actually at DC, right? So you're also suggesting that we should not keep everything in just one that's working in one fashion. We should not be only Amazon enabled DC as well.
We're getting to I've talked to a lot of companies now that are in multiple clouds for sometimes just cost reasons. Because Google infrastructure is got some amazing things that it can do. But maybe there's some features in Amazon that you really need. Well, you can live in both now. It is possible. But if you're going to be in one provider, at least, and this is all based on your risk profile, maybe you don't care so much. Or it's just not, the money isn't there to meet that. It's always a cost equation problem, right? because adding more infrastructure or like spreading your infrastructure across 2 regions means your Amazon bill just went up. Or if you're in another provider, that bill is now there. But if really your business depends on having uptime, that's the discussion. That's when you need to have that discussion. One of the interesting use cases I saw with using Amazon and say Azure or Azure and Google is around storage price on certain type of models. Like Google has a really good analytics platform, and it's really cheap to store your data there and analyze your data. Azure has a really good application, or has a really good regional footprint. Way more data centers than Amazon. And so you get, if you're running, say, a mobile application, you may want to have your app being hosted or being distributed that close. So, they have data centers in Midwest, not just East and West. Places like Africa and Australia, all over Asia. So you may want to put your application infrastructure in Azure, but your data reduction and your processing infrastructure in Google. Yeah. Yeah.
We actually use DSP where I work, but we
Cool. You want a sticker?
we actually use a really old version, and we're trying to get into the process of upgrading. But we actually use bare metal.
Mm-hmm.
So personally, we've always been told, like there's the old Apache Cassandra 1.2.
Right.
That's really old.
That is pretty old, yeah.
Yeah, but we were always told bare metal was better than VM or even cloud. So now we can say that it's better now to go towards cloud. Because as we grow in the company, we're slowly realizing we need to expand our capacity.
Right.
And getting new servers and stuff like that is
Bare metal is always going to be, well, probably if you're going back that far, bare metal versus cloud or VM back then, yeah, bare metal, you'll always get better performance head to head. But let's face it, back then, an instance at Amazon was like an M1 large. That's what you had. Now everything has SSDs and Xeon processors. It's a totally different game. So it's a good time to do that for sure, but it's also inevitable. Racking up hardware anymore almost seems old-fashioned. Yeah, but here's the thing. Since you're already there, you can set up your infrastructure in Amazon, and since you're already using Cassandra, I just showed you how to do it. Create another data center there. We call it inchworm upgrades. You stretch your data center out. I worked with a company that moved data centers 3 times with no downtime because they did that whole business. And then they use their application infrastructure with DNS to route the application traffic, get everything right. So the key, here's something I learned at Yahoo. The key to application uptime is pushing your state down to the data layer and dealing with that replication problem. Once you do that, then the application, it's easy at that point. But you're in a good place. You just need to upgrade.
we're getting there.
We have a new version. It's really nice. Here's the thing, since we're all friends now, we have some pretty exciting, significant changes coming. There's been about a 2-year engineering effort to increase the performance in DataStax Enterprise when I saw the numbers, I kind of thought they were fake because they just seem fake, but we keep doing it. And it's really because we've known the system I've been working with Cassandra for 7 years now. We know how it works. We know the inside and out, and we know where it's slow. And we have some engineers that are finally chipping away at some of those bottlenecks, and wow, it is fast. You hear Scylla talk about, we're X amount faster. We're going to dust them. I was really surprised. So, yeah, I'm surprised those guys aren't in here. Usually they come to every one of my talks and pass out T-shirts. But, there's some exciting stuff coming. And if you're into security, the DSC 5.1 security it has row-level access control now. So they're really good security profile. So, yeah. All right, guys, I guess it's time for lunch, huh? Appreciate it. Is it? What time is lunch here? Oh, okay. Almost. Any more questions? You can use my consulting brain all you want here.